Hello, Math 2 students. All right, as my other class is watching me make this video, could get kind of awkward. All right, you guys think talking to a computer screen is easy. All right, so the first one you had for homework last night was if customer service receives an order for 3 blocks that are each squares with both dimensions increased by 2 in comparison to the basic block, again, show two different equations for the area and verify your work as a model. Now, period 1 found that starting with the model was easier. So we have two basic blocks, right? Oh, sorry, three basic blocks. And each dimension was increased by 2. So we have these sides increased by 2. Okay? So when we go to do this one, right? We know right away the area of this, each of these, is going to be x plus 2 all squared. And we have how many of them? We have 3 of them. Let's use the handwriting here. So now right away we know we have 3 times x plus 2 all squared. But the one thing we have to keep in mind is how many did we have to add in here, right? So basically, this is one expression, but the other expression would be, you have your 3x squared. You have now 2, 4, 6, 8, 10, 12x. And then how many little ones do you have? 4, 8, 12 little ones. So this would be two equivalent expressions for that one. Okay? Now the next one's a little more challenging. You too. Clementine is on it again. What is that dog going to learn not to chew up the orders? Here are some of the orders that have been chewed up, so they are missing the last term. Help Optima by completing each of the following expressions for the area so that they describe a perfect square. Then write the two equivalent equations for the area of the square. So what do we have to add here? That's the question. Now, many students have probably put 16 in there, right? Because they're used to taking half of 8, squaring it to get 16. But if I put 16 in here, it doesn't work out. So what do I have to do? Let's start with a diagram. I know I have 2x squared I have to distribute. Okay? There's 1x squared, there's 2x squared. Now if I have 8x, and I have 2 squares to distribute to, each square is going to get 4 x's. All right? So this gets 4x, this gets 4x, which is 8x, but I have to distribute to the sides evenly, so I get 2x and 2x. So now when you think about this, right, how many little x's or little ones do I have to put in here? 4 here and 4 here. So how many did I have to add to make 2 perfect squares? I had to add 8. So if we talk about this logically, what are we basically doing? Well, how many squares am I making? 2. What is the dimension of each square? Well, the dimensions are x plus 2. So we have x squared in one, and then we have, we have x squared in one, and then we have 4 x's in another one, 2 on each side. Oops, sorry. Why is this acting goofy? All right. I do not know why that's happening. So let's try this again. Plus 4x, right? So this is the dimensions of that. If we complete the square on this, right, we would take half of 4 and square, which gives me 2 squared, which is 4. So what did we really have to add inside here? We really added 4 inside. But if I have 2 of them, 2 times x squared is 2x squared, 2 times 4x is 8x, 2 times 4 is 8, right? So we have to add 8 here to complete the square. So now, one equivalent expression would be 2x squared plus 8x plus 8, but this would simplify to 2 times x plus 4, or sorry, x plus 2, sorry, all squared. All right, so let's take a look at another one. All right, I want you guys to pause the video and try and duplicate on that second example. So here, how many squares do we have to make? We have to make 3. Now, we have to make 3, and we have 24 x's, right? How many does each x get? All right, each x will get 8 x's, right? Because 24 divided by 3 is 8, which means each side gets 4. Now, to save time here, if each side gets 4, right? I know right away this is 3 times x squared plus 8x, right? So now I have to figure this out. Well, right away, each of these will look the same. But how many little blocks have to fill this in to make it work? Well, 1, 2, 3, 4. How many blocks are in here? 16. So if I go to complete this square here, in this section here, I have 16. I have 16 here. I have 16 here. And I have 16 here. What do I have to add here? 16 times 3 is 48. Okay, so, why does this keep jumping? So if we add 16 to each one, right? 3 times 16 is 48. So 2 equivalent expressions here. 3x squared plus 24x plus 48 or you could do 3 times x plus 4 all squared. So I want you to pause the video and attempt number 6 and 7 on your own. All right, first start with 6, and I'll have another video for that.